Today is basically our first topic on urban land change. If you have the syllabus, so basically we scheduled for 2 weeks on urban land change, and today we're going to focus on urban growth modeling. And basically I'll be introducing some different modeling approach, which include some basic ones that you folks have heard of, like multiple criteria evaluation, statistical modeling, but also there could be some new models that you haven't been using or reading before. And today we also have an article review by Chad, which I assume will happen after the break. And then we have a project prep assignments discussion. This time is about developing your reading list. And also I emailed you earlier today, and maybe we can take the opportunity to try some Zotero. And I did see, well, actually Zotero can be added into Word as a plugin. And also you can use Zotero on Google Doc, which is, however, very slow. And they did mention the issue, like when you have more than a certain number of citations on Google, if you're using Zotero on Google Doc, it will get even slower. But either way, I think it's pretty functional as a free tool. So in terms of urban growth models, so let's do another word cloud. So first of all, like, I'm sure you folks have heard of, the word model, or maybe you have been doing models. So whenever people talk about modeling, or you can also be more specific in urban growth modeling, how would you define model? Or what's in your mind whenever people mention the word model? I guess model can also be a verb.
So when defining,
Emily, we're doing the Slido again.
Oh.
I appreciate that you're trying to participate. Let's do the word cloud. And then, yeah, I think I'm sharing. Yeah, I'm sharing my screen. Simone, do you see the Slido? Yeah, I think in some way, I hope maybe there's a way to generate word cloud from Zoom chat. That would be convenient. I wonder what scenarios, not scenarios, mean. Testing.
I misspelled scenarios, and so I rewrote it. And I couldn't erase it, so I had to rewrite it.
Okay. Yeah, assume that's mathematical. Okay.
Yep.
Yeah.
Yep.
Okay, I'll be waiting for maybe another 10 seconds if you have some more to add. Prediction wins.
To access this, all they have to do is point their phone camera at this. You can go to slido.com too and type in the number 61557.
Yeah, slido.com. Thanks, Blake and Chad. It's okay. I mean, we can also just read the chat. It's okay. I think as long as it's something we all can access, that's good. Okay, I can see there are a lot of prediction. And also, well, we have some of the keywords: representation, scenarios, process, mathematical regression. Some are really specific. And some of you are talking about, I guess, what you can model, urban land use pattern, growth and decline, automate computer models. They're all automating the process. And we have a couple words here. Judy said algorithm. Okay, so I think that would give us enough to begin with. I just want to begin, want to make sure that we're on the same page regarding what a model is. So let me return to my definition page here. So I'm taking some definition of models from the literature, and they're all pretty much defined in the 70s, 80s, and 90s. So in general, I think you all captured what a model can do, or in the urban environment, or what we can use a model to model. And some of you mentioned mathematics, and some of you mentioned regression. Those are all very good examples of models or testing a theory, doing prediction. And they're all very important components of models. And in addition to those, general definitions of models, I would also like to share one definition I learned back in grad school. So basically, when I took my research methods class, the professor basically said we actually did some reading on modeling and in the field of biogeography. So anything that helps you learn is a model. So in that case, I believe back in high school, in your biology class, the fruit flies can be our models. You learn a lot of like the DNA stuff through the examples there. And today we're going to focus on mostly computer-based model and also statistical model. Some models are simple, but also some models can be really complex. But either way, we're trying to study and testing theories. And also another statement, maybe you have heard of, all models are wrong, but some models are useful. So that's something really important to keep in mind, because you'll never be able to model the reality in a full extent. You have to be omitting some details and just focus on the question you have. And models are usually true only on a relative scale, that you're trying to approach your question, trying to study the relative importance of the factors, and trying to do the prediction so that you can try to answer the question or solve your problem. And also here, in terms of what a model can do, we all mentioned prediction, of course. So we use models to predict, not only predict into the future, but also models can be used to simulate and basically simulate what happened in the past. So there has been some historical models based on the recent data to simulate historical urban development, from the 17th century through the most recent year. So this is one of the roles model can take. But in addition to a prediction, models can describe a process. So basically, when you're trying to analyze different factors, the spatial and temporal space, and also trying to learn in the urban environment, we're trying to explain and describe how the drivers are affecting the land use patterns. And I would say that explain and describe, they go together depending on which ones you're trying to focus on. And in addition to bringing in the driving factors of urban growth, of course, you can assess the impacts of land change upon the environment, upon the society. I recall earlier we did this, like what interests you the most, some topics you folks like to explore. some of you mentioned like urban infill development or, the different vacant lots reuse, but also I saw many discussion on urban development versus the environment and also society issues, mental health. So there are many different factors you can explore, not only by predicting the patterns, but also assessing what is going to happen, if the sprawling patterns are going to continue, or, the pollution issues, some of you are interested in the social impacts, poverty, segregation, and even, psychology, mental health. And the last row of models can be prescribed. So this is another important use of models. I think it actually goes with prediction that you can perform scenario analysis to say, based on this particular scenario, what is going to happen. And then in that case, we can try to figure out the so-called optimal land use patterns for sustainable development. That sustainable can have multiple components, and that also goes with the different impacts. So a model can do different things, and basically that's our experiments that you can do by simulating the process and trying to better understand the different factors and the different dynamics. And for today, I'm going to focus on 4 different categories of models. And if we can further categorize the models, I would say the first category, cartographic models, is something you all have been doing. Basically geoprocessing. You can perform geoprocessing through combining the different tools within ArcGIS or within a different GIS program to achieve certain results. And statistical models, of course, that's an important category, and we are going to focus on specifically logistic regression and the artificial neural network. And I would say the cellular automata and the agent-based model, they go together, although, of course, the technical perspective and also the conceptual specifications between the CA model and the agent-based models can be different. So we're going to have some activities there and some examples along the way. So first category, the cartographic modeling. So like I mentioned, it's basically refers to this category that you will be using different geoprocessing tools. You create buffer, you overlay your layers, and sometimes you may have a raster layer that you will reclassify them, you perform interpolation, or eventually you may do a multiple criteria evaluation to combine the different factors together. And suitability modeling is one of the primary example. You can bring in multiple criteria. And I believe you all did something similar in 391, the graduate project, by evaluating a few factors and weighting them and combining them together. And in urban land use and land cover, you can do similar ideas, but your factors will be related to urban development, driving factors, and you can still weight them and combine them. And the same thing can happen on a raster format. So one primary characteristic of this cartographic modeling is, it's kind of static, although you can do the same suitability model to say, to study different years, but usually what you study is only one time step at a particular, maybe you study 1990 and then you study 2000 and 2010, 2020, and you can compare the change. However, each group, each time, each set of data is static. You're not really going to study the process, or you're not going to analyze, animate the changes over time. So it's, relatively speaking, is only static temporally. So we're going to, take a look at an example, because I felt like you folks are familiar, with the idea. So this article I'm using is actually quite old. So it's published in 2003, but I'm still using this article because it's a very interesting case. that they have combined 3 different modeling components. And actually, I would say among the 3 different components, the rule-based suitability model is more falling into the category of cartographic modeling. However, they also used a statistical model, logistic regression, which we'll talk about shortly. And they also combined with a qualitative component. So overall, it's a mixed method study, which, as I heard, many of you will be doing some sort of mixed method study for your future final thesis. And this has been the trend, as I remember in the past several years. Many of our grad students are doing some sort of mixed methods research, bringing in qualitative information in their statistical modeling or GIS analysis. So let me actually return back there to just to talk a little bit more about logistic regression, because this diagram is actually only about this rule-based suitability model. So among the 3 models, they use logistic regression to basically use historical data and to study the patterns between a number of predictors. So specifically, I believe they considered 15 different driving factors of urban growth, which include some accessibility factors. For example, the factors that we have been talking about: distance to transportation, distance to existing urban area, and they also considered population and environmental factors. And they built this regression model to predict where the future development are more likely to happen. So they have the first layer from the logistic regression. We'll talk about the mathematics shortly. And they also have the rule-based suitability model, which are basically used to bring in the policy factors and environmental factors. For example, they use the rule-based suitability model to exclude the conservation area or areas that has been already been developed. And they use the qualitative component basically to complement what is really missing in the statistics models by inviting the stakeholders and including developers, landowners, and the community leaders and different, the local experts to digitize the future development scenario or according to their local knowledge. And this is actually a demonstration of their second modeling component, the suitability model. So you can see they have considered a couple different factors. So the first group is what they define as rankable variables. And this part, even if you may find the formula is a little bit hard to understand, but in general, it's a multiple criteria evaluation. So you can see the weights determined for each factor. It's a raster-based analysis. So they're combining the different ranked variables. And in that case, they can predict a suitability score for each location. And they also have 2 other groups of variables. The second group is called superposing variable, and the third one is excluding variables. So you can rate, they're excluding water, wetland, and protected land from the development. So by combining all the 3 groups of variables, and they calculate a relative suitability score for each individual location. So that's their second component. And also, all this part essentially is all from, data pre-processing or geoprocessing. For example, the different factors or distance to major roads, you can calculate a distance raster. And for the different population density or the different land cover slope, you can derive from digital elevation models. So all of this are specifically derived through some geoprocessing tools and then combine them. And here is their results and integrated model. So this is logistic regression, and this The top one is the rule-based model. And the one on the right side is their focus group prediction. So you can really see the pattern difference. And apparently the focus group prediction is relatively, in general, the shapes are simpler because they're all digitized by the local experts. Especially, they're just given a base map and they're just drawing based on their knowledge about the local geography, the context. And the logistic regression gives you more, I would say more detailed patterns or fragmented patterns because it's all from data. And the rule-based models are relatively similar, but also you can see how they're following the different land cover systems. And eventually, taking into consideration of all the three different models, they did a linear combination to generate the final integrated model. So the final model would reflect a linear combination among the three. And also actually, this is another layer of multiple criteria evaluation. So to generate their final integrated model, they consider the logistic regression, the rule-based model, the focus group as three different criteria, and then they weight the three different criteria. And they mentioned they're using, instead of using a statistical approach to determine the weights, they actually took a trial and error approach just by trying different values and see, which one makes more sense. So finally, they generated a integrated model by further combining the three using essentially a multiple criteria evaluation approach. And another component of this research, this case study, is they also did a scenario analysis. So basically, they're doing predictions into 2030 based on different growth ratio. And growth ratio is also known as the sprawl index that you folks will be reading in the coming, well, basically the reading assignment for this coming week. We'll talk about urban growth, urban sprawl pattern measurements and landscape pattern metrics. So they did specifically mention the equation for sprawl index. So essentially the idea is they're comparing the growth rate of developed land versus the growth rate of population. So if so the idea is if the land growth is higher than the population growth rate, it would be considered as more sprawl. If the ratio is 1 to 1, and they're considering it's the same sprawling speed. And if the ratio is less than 1, it will be more compact, less sprawl. And apparently, as they increase the ratio, you will be able to see the pattern. So it's not only about the overall amount is increasing, but it's more likely the pattern will change depending on the different growth scenario. So that's actually one of the definition or the use of model, as you folks pointed out. Models can be used to study the scenario and to predict into the future. And we're basically using models to do some experiment to see what if, like, the what if scenario. So what if is, the growth rate is ratio is 6 to 1, what is going to happen? Not only the overall development that is 991 square miles, but you can also see the pattern. And more specifically, you can analyze the environmental impacts or the related issues caused to maybe pollution and transportation. So that's the first example, although the cartographic modeling is only one of their three different components, but I would like to share this example. I can also send you folks I can probably send you later on. Let me see. I actually have the article right here, so I can send the article to you in the chat so that you can, I believe it should be this one, so that you can take a look later on if you're interested. Okay. So it's a PDF. In the second group, I'd like to focus on is the statistical models. And in 442, and also if you're taking some other statistics class at the graduate level, you'll be learning mostly, the ordinary least square model, linear model, and then maybe multiple variable regression. And today we're going to focus on logistic regression and the artificial neural networks, which are also quite popular in terms of modeling urban land change and urban growth. And also, because I know not everyone has taken 442, or you'll come with different statistics background. So feel free to jump in if you have any questions. So first of all, just want to mention that ArcGIS Pro has incorporated a logistic regression as one of their tools under spatial statistics. So that's great news, because I used to build logistic regression in R, or you can also, of course, use different coding platform to apply logistic regression. But right now, it's possible in ArcGIS Pro. And the tool, so if you search logistic regression, I don't think it will pop up, because the tool in ArcGIS is called generalized linear regression. So I just send you folks the name in the chat, GLR, generalized linear regression. So actually logistic regression falls into the category of generalized linear regression model. So that's actually the case with many other platforms. By using R, there's even a function called logistic regression. You still have to use the generalized linear regression, and then you specify that you're going to use the logistic regression methods. So, so last time, I think it was last time, I think I probably mentioned the idea of using logistic regression. So just a quick recap. Logistic regression is used when you have binary dependent variable. So in irregular case, when you run the ordinary least square regression model, your dependent variable is supposed to be numeric values. For example, it could be population density, it could be the amount of urban growth, or it can be, for example, maybe income, or the percentage of some population, or some estimation of values. So either way, the traditional regular linear regression would be using numeric values. However, in some other cases, you may have binary dependent variables. So in our case, in the urban growth modeling, if you're thinking about a landscape with either pixels or land parcels, it's either developed or not developed. So it's a binary variable in nature. And also this logistic regression approach, by taking into consideration of the binary dependent variable, it would allow you to really model the detailed location-based, really study the geography, because otherwise you probably have to aggregate your data. For example, you have to aggregate your urban pixels by, maybe by hexagons, or by a higher level, or by tracts, or by counties. But by using logistic regression, we are basically given an opportunity to study a location-based urban growth and also the related factors. And so what the logistic regression predict, so after you run the model, what you're predicting is the probability of urban growth in the future. Or if you're trying to generalize logistic regression for maybe other study, not in the urban environment, for example, you can use logistic regression to model, wildfire, either yes or no, and you can consider the different factors. Or you can use logistic regression in a species model, the either presence or absence of some species, and you can consider some different environmental factors. And you can use logistic regression to study, any cases you have this binary dependent variable. So what do you predict will be a surface of probability? For example, this location has 90% of probability being developed, and the other location has only 75% of probability being developed. So each different location will get a probability value after you fit the logistic regression model. So speaking of probability values, so we know probability would range from 0 to 1. So that's the case. And for those of you who are familiar with linear regression, so or even if you're not familiar with linear regression, so let me just quickly draw something. Sorry, actually I'm trying to draw the X and Y axis in this Cartesian space to get the sense. So when you predict a linear model, so basically your model will be fitted as a line. So my question is, so when you fit a regular linear model, what would be the possible range of values for your predicted Y variable or your predicted dependent variable?
Well, that's depending on what you're inputting into it. Right. So, so whatever you're going to climb on the y-axis, you're going to have to denote that, you're adding y, basically y equals some value plus.
Right. So, basically y equals a plus maybe bx or maybe multiple variables. Yes. Like Ritis pointed out, it depends, but also technically it just can go up or go down. It can achieve infinity in a regular case. But however, we want the probability, we want our y to be from 0 to 1. So that's actually the reason why the regular regression wouldn't work in this case, because they just won't give us 0 to 1, which is what we want in terms of predicting probability. So in this case, we introduce the logistic regression model so that we can get what we want. So instead of using the y directly as your dependent variable, in logistic regression, they introduce the odds, which is basically the probability of something happening, the ratio between the probability of something happening and the probability against something happening. So this is a question of calculating the odds. And also the reason why this model is specifically known as the logistic regression is they're actually taking the natural logarithm of the odds to make the variables more suitable for the regression. So here, let me show you quickly of what this means. So here will be some mathematics. I hope I make sense, or I hope that we can be on the same page. So I'm using R to draw some diagram here. So what I'm trying to do first is I'm going to generate a list of values ranging from 0 to 1. Well, basically that's our y. So, that's my y's with a 0.001 interval. So I have many different values that is ranging from 0 to 1. And then, I'm taking, let me first do the odds. So odds will be calculated as y divided by 1 minus y. And then, let me just copy and paste. And then I can plot the range of the odds by the calculation. Simon.
Sorry, is this through R? or Python?
Yes, yeah, I'm doing this in R, but you can
Yeah.
just only focus on the, the plot here. So if I plot this out against the Y, and you can see the range of values are going to only be positive. So which is, again, not really natural for linear regression because you may predict negative values. So by further taking, actually already assigned, but I can show you once again, just to confirm. So by taking the natural log of the odds, and then if we are doing the plot again, and you can see, so by taking the natural log, it doesn't really go that far, but eventually we're converting the value to a form that would go to, infinity, negative infinity to infinity. So this conversion would allow this general idea of linear regression to carry over because, eventually logistic regression is still based on the similar idea. They're just taking a different form of the dependent variable. And also, if you're not really okay with dealing with, the mathematics, actually you don't have to. It's just more about running the tools eventually because, the program will do the mathematics based on the data that you input. And also, if you're interested in learning the equation, so for generally the regular linear regression, we know it's y equals a plus bx if there's a single variable. But for logistic regression, the equation is written as the log, the natural log of the odds equals a plus bx. So once again, you don't have to build the equation for yourself. However, the program will basically plug in your y and your a. And predict your A and B, the y-intercept, and also the slope coefficient. And also I can show you a animation of how the model is fitted. And what is different than the ordinary least square regression model? The model is fitted through a different algorithm, the maximum likelihood estimation. So the idea is very similar. They're just trying to achieve the best estimation. Different algorithm, but similar idea. So we know your input y would be only 0 and y. So this little blue crosshairs represent our actual data. So the model is fitted just to achieve each end, and so that we get the best results, but get the best curve. And this curve will tell us what are our y-intercept and what are our slope coefficient. So just an animation of the model fitting process. And if you're interested in the tool, you can go to, let me also send you the page for the ArcGIS tool, generalized linear regression. So logistic regression is now part of ArcGIS Pro. And we have seen this example earlier. So this is the example article showing you the logistic regression, and they specifically considered the the coordinates locations as a way to account for spatial autocorrelation, and by using a number of 20 different predictors, and their dependent variable is binary. So either urban growth or no urban growth. And their final results is a predicted surface of urban growth probability. So the range of values will be from 0 to 1. And also usually, this process of estimation, estimating the probability wouldn't be the last step. So based on the probability, you can predict the future scenarios And also by looking at the future scenarios, you can bring in other environmental factors, once again, social factors to predict the impact. So just some general comments here regarding logistic regression. Sorry, I have some issues here with my privacy. So the strengths of logistic regression model is very similar to linear regression. So you can consider different drivers, and the model will tell you the relative importance, the impacts of each factor to the dependent variable, and also you can use data at different scales. So usually, by using raster data, you can aggregate your data at different scales and analyze how the pattern change and how the relationship change by the different scales. But in addition to the strengths, this model also has a number of issues, and eventually they're learning from data. So the scale matters, and also what factor you're trying to simulate also matters. So it'll be really hard for you to generalize if there are missing variables, or if you're looking at patterns at a different geographic location. And also, like I think we mentioned earlier, the model itself doesn't produce future projections. So you really have to do some other simulation. For example, you can estimate future total amount of development, and then you can allocate the future, the total amount of development based on probability, so that, for example, higher probability will have a higher chance of getting developed in the future. So the idea is I'm predicting in the future. So in the next year, there may be a total of 500 square miles to be developed. And then you can allocate the 500 square mile based on suitability, based on probability. Higher probability locations get developed first. And then, the allocation will happen in a step-by-step manner, that over time you'll see more locations are being developed. So it's all based on their ranking in terms of probability. And also, I want to take the opportunity to just briefly mention artificial neural networks, but we won't really get into too much technical details of the ANN model, the neural networks. But either way, I mean, the concept shouldn't be too new, because neural networks have been used in urban growth modeling back in the 90s. Although, as you folks know, nowadays we're talking about artificial intelligence, machine learning, and deep learning. All this different algorithms are used in pattern recognition, in image classification, and also in terms of doing different urban models or model different processes. But actually has been used in the field of urban growth modeling a while back. So the idea of neural networks is eventually, I would say, is still very similar to the traditional statistical models, regression models. So the idea is, for example, you'll be inputting a bunch of different variables. In this example here, they're considering 6 different factors that may drive future urban growth. And this artificial neural networks, so the basic element within the ANN is a neuron. And each neuron will be connected to the different layers. And you can have one, so here they say a hidden layer, and you can have multiple layers. So they're basically building this network to make connections between the different elements by learning from the data. So that's just where the name came from, machine learning. They're learning from historical data and just to learn the past patterns and trying to make predictions into the future. And the reason why they're calling it a hidden layer is just because essentially it functions as a black box. And you don't really know what exactly happening in the hidden layer. So what they're trying to do is they're trying to simulate the pattern based on all the input data and trying to make connections, weighting the different layers to achieve the best results. And it's it's an iterative process, and they're just doing this over and over again and trying to make different connections and try different ways until they achieve the best prediction. So what you can achieve usually say, if you're providing a good number of driving factors, the prediction results can be very high, the accuracy can be very high. However, the artificial neural networks are not good for explanation because you don't really know what is happening here. It's all about data mining and looking at how data are related to each other, and also bad data in, bad data out. So if there are any mistakes, they're all in there. They may mess up all the relationships. So, and also as an analyst, since you don't really know what is going on inside there, you probably wouldn't even detect the errors yourself. So that's about artificial neural networks. And in general, you would apply artificial neural networks through external program because coding skill is required. For example, MATLAB can be used to build artificial neural networks. And I know there are also some libraries, but you do need some bit of coding in order to put everything together. So in terms of the advantages, first of all, it's non-linear. All the models we have talked about so far, they're still based on this linear regression structure. So it's non-linear, and it's also non-parametric, which means you don't have to rely on this normal distribution assumption and just to test all your model assumptions. They're free from data distribution, and also they're able to learn from the data. Relatively, they're pretty good at doing the prediction. You can incorporate different types of data, numeric data in the different categories because you're going to just learn the patterns from your data. But really the problem is we mentioned the black box issue. You don't really know what is happening in the hidden layer. There's no way for you to explain what factors are really important that makes more sense and what is going on in the hidden layer. And I would also add that they're actually oversold because I have read some articles in actually not really urban growth model because they don't really report accuracies in a very detailed manner. But in the field of image classification using artificial neural network, I have seen people classifying very broad categories, but somehow using artificial neural network, but only achieved a 80% of accuracy. However, because I'm doing a lot of image classification myself, by really carefully selecting training samples, by selecting your input data, it's actually pretty easy for you to achieve even a better results by using a simple, basic methodology. So once again, it's great. They automate the process, but actually the analyst will determine everything. And also, you have to prepare your data. And if there are any mistake, any errors, they will go into the model and they will impact your results. And if you're doing image classification, selecting training samples is also another skill, careful and also accurate doing analysis. So there's still a lot of human input in there that would affect the performance of your computer model. And after the calligraphic modeling, and also the statistical modeling, I would like to mention another category of models that are used to model complexity. So this idea has been there for about 2 decades. I mean, of course, people have been studying this, but recently in land change modeling, you have seen more cellular automata or agent-based models. So 2 keywords to characterize this group of modeling technique. The first keyword is emergence. So the idea is they're studying they're basically setting up individual level interaction rules between your individual elements, whether it's a cell or whether it's an agent. And then you'll be observing the whatever pattern that would emerge from this local level interactions. And also, well, actually they go together. So because our focus in this group of models are on the local level, the individual level, we would consider them as a bottom-up approach. So, traditionally for statistical model, you just bring in your data and run some model and you build one equation. Or for geographically weighted regression, you may have multiple equations at each location. However, there's still like you're looking at things from the, from a top-down perspective. This group, the CA model and the ABM, they actually go from the bottom up. They study local level behavior, local level interactions, and then whatever happening at the global level or the macro level can be a surprise, because you wouldn't know until you observe all these patterns emerge from the local level interactions. Okay, so let's try something first before we move on to talk about the model details. So for a cellular automata, so the idea is really what we have tried. Each of the cell will have some status. In the urban case would be urban growth or no growth. And also you can define a set of transition rules based on their neighbors. You can define their neighbors. And also, actually that was a good question. I think it was probably Amy or several of you asking about like how do you define your neighbors. That does matter. You can define your neighbors to be only the 4 or maybe the 8, and you can define multiple layers of neighbors. So either way, you define the transition rules so that each cell can interact with their neighbors, and overall there will be creating a pattern from this kind of local level interactions. And one example here is actually one of the classic CA model developed by Clark back in 1997. So the model is called SLUIS, and the SLUIS model basically stands for slope, land use, exclusion, urban extent, transportation, hue, shade. And the model was originally designed for modeling a city in California. So, as you can see, slope and hue, shade, the two factors, they do matter. So like when people apply the model to some other locations, you probably can further customize depending on the local scenario. In Chicago, slope and hue shade may not be a big factor, but you can consider some additional factors. So the SLUIS model is developed on a raster format. So the idea is you just have each individual layer to represent a factor, and you can define more complex rules to develop a cell or not to develop a cell, depending on their distance to the different factors, or depending on the different types of urban growth. So this is one of the very interesting and classic model of the cellular automata. So overall, as you folks can see, it's pretty easy to understand. When you can define the rule, which can help you communicate with, like the rationale and how the model works. And you can also predict very complex patterns, because you never know what is going to happen. It will be just interactions at the local level, and then, different things will emerge at the global level. And relatively speaking, CA model is not very flexible. So I'll be talking about the agent-based model, and then I think it would make sense why the CA model isn't very flexible. So one example being, the individual cells, they couldn't move. So which actually limit the function of the model. You couldn't really model mobile entities. And also, depending on what you study, so sometimes it may not be possible to incorporate all the driving factors. Agent-based model is actually along the same line, very similar. And actually some agent-based models are essentially cellular automata, but also agent-based model give you additional layers of information would allow you to model additional factors. So for agent-based model, similar to the cellular automata, it models individual actors. However, because of the incorporation of agents, because you can use agents to represent individual objects, and in the urban growth modeling environment, you can use agents to represent residents or developers or governments. So agents can be anything, and agents can also be individual parcels of land. So what is different than the CA model? The agent-based model would allow you to actually model the agents separate from their environment, if I make any sense. The CA model, essentially for the CA model, you have to model land-based scenario. So the land is being developed or not developed. However, the agent-based model, you can use agent to represent human behavior, basically, or different agencies, institutions in the environment. The land can come from a different layer. So this would allow you to model, further model the interactions between the social factors, the individual actors, and the land, or the society, the environment. And also is, of course, another bottom-up approach. So for the agents, similar to the cellular automata, you also have some attributes, a state. And also you can use agents to model their different perceptions or behavior, and they would change their state based on rules. So essentially, the idea is very similar to cellular automata. So one example here is an article published in 2007. So actually there has been some research a decade ago studying using agent-based model to simulate urban growth patterns, urban forms. They're actually doing a two-scale, multi-scale study. So at the macro scale, a broader scale, a global scale, they used a linear regression model to estimate the total amount of change. And then, the global model would also allow them to consider some, policy factors, including maybe restrictions by, the planning policies, or, some other considerations, and maybe, economic policies. And that at the micro level, the local level, they allocate the total amount of change determined by the macro level model by assessing the individual, the suitability and the preference of the individual agents. And the agents are free to move and search for the entire space. And also they consider the forms of development by separating a master agent versus the following agent, because they do consider in this, basically the cluster, the pattern of urban development by first picking out a random location, and then there will be some neighborhood allocation following this agent. And basically compared to the cellular automata, the agents are flexible, and your agents can move, and your agents can, so it's not really confined into the local neighborhood. Your agents can maybe jump to a mile away and just to look at available land there. And you can also model your agents, and also between your different agents, you can separate, for example, the residence agent can interact with the developer agent, and can also interact by, with the government agent. So, just as long as you have the solid scenario built up, you can incorporate very complex rules in your agent-based model. But actually, one of the major problem is the complexity within agent-based model. So first of all, it's all possible because all the different layers are available, and all you need to do is to set up the rules and make sure the interactions are modeled properly. So you can model the interaction between the human agent and the environment, and also you can go across different scales. But complexity is really also the problem because I did some agent-based model at grad school. So the problem is it's hard to simulate or generalize human behavior. So unless you use agents to represent individual person, the perceptions may be different. The decision making can also be different. So what people usually do is they would have a group of rational agents who would follow the general rules, but they also have some other, maybe a certain percentage of random agents who would just search the space randomly and develop randomly. And the issue of error still exists here. And another issue is just data issues. So one trouble I had was just about defining the information, and I have some ideas. However, the data may not be available at the finer scale in terms of how the behaviors interacting with each other and the factors are determined. And also in terms of the technical component, you can build the CA model and agent-based model in NetLogo, which is a program we'll be using later this semester. And actually there was an agent analyst extension to ArcGIS Desktop. And right now, I haven't seen their updates on making the same tool available for Pro. And hopefully they will have something. So I think the integration would be really nice because by building the agent-based model within ArcGIS, you can map your data, and you can also combine with geoprocessing very easily. But right now, I hope it's still under development. And back in grad school, I did my agent-based model using Java, and that was there was a library, but still, like personally, I didn't really like the overall structure of Java, which is really complex. There are different documents connected, and just every single time, like for some simple change, I have to modify multiple places and multiple documents. But anyways, there are some easier non-coding environment available right now, and hopefully the agent analyst will be back for ArcGIS Pro soon. Okay, I think that's my last slide. Should we take a break, and then we'll come back for
Sure.
article review. Recording. So for the reading list assignment, I'm looking for the 15 articles. I know right now, some of you had your questions developed depending on, I know many of you have many different interests and you're still trying to narrow down or, just basically find out a specific idea. But either way, I felt like everyone has a general direction. So this assignment is about searching for articles that are related to your research topic. And if you don't really have a question, that can be just in general, your topic. For example, for Chad, it would be urban gardens, and also, the placement and the reuse of land. There can be some different articles related. And also for this list of articles, you can try to include some more like conceptual articles or literature review type of articles. It doesn't really have to be only GIS-based empirical studies. You can talk about the conceptual issues. For example, all the discussion related to like food access, and also it can be non-GIS, can be conceptual, can be review. But also among the 15 articles, you should have several articles on how GIS has been applied in the field of study. So in terms of how many, I would say it really, the way I'm thinking, at least, 8 or 9 articles are probably should be GIS applications in the field of study. So I guess my general recommendation is you will want to stay, I guess just the articles are, ideally, they're highly focused on smaller issues, not like really broadly speaking, like if we search GIS and urban growth, for example, you will have a lot of results. However, if you search agent-based model, urban growth, that will help you narrow down. So just, like you can focus on some techniques, you can focus on more specific factors or issues. So just, more articles. And also, I hope in this way, like by reading more and searching for more articles, we can try to make progress towards finding out some research questions. Because I know, we're just trying to get started early. So this is a process. If you don't really have some ideas, the only solution is just to read more. And by reading more, you will have better ideas. So that's just the whole point of this this assignment. But of course, I'm not really looking for like a thorough reading of all the different articles. What I need you to turn in is a document with the list of articles in APA style, and we'll talk about Zotero. That's why I would recommend using some sort of literature organization structure software. So you'll have your list, 15 articles. However, I want you to categorize or organize your articles by categories or by sub-questions, so that you just, instead of just throwing at me 15 articles by a list of, in alphabetical order, I need you to classify the articles just to demonstrate that you know what you're doing and you know what the articles are about and you know how you're going to use the articles. So the way I'm thinking, for example, the way for the recommended, and also I think this is a basic way of classifying articles that would apply to many of you, the questions you folks had in terms of GIS application. So you may have a couple articles on why is the proposed study important. Here for the first category, I felt like many articles into the first category can really be non-GIS. For example, if you're talking about food access issue, or you're looking at urban geography in general, you probably want to have a few urban geography articles or more like articles talking about the problem. It could be GIS, could be more general. And then the second category I'm thinking is why spatial analysis and GIS is useful in this field of study, right? You have the problem identified, it's important, but where's the spatial component? Like why GIS can be important? And the last category I'm thinking is how has GIS been applied in this field? Like basically examples of specifically GIS, how GIS is used in this field of study. So this is just, the way I'm thinking, because, depending on your specific question, your way of categorizing or organizing the articles can be different. But if you don't really have any ideas now, I would go with this structure. But if you do have some specific ideas in mind, just anyway, as long as it makes sense. For example, if you're interested in more technical issue, you can actually review, maybe 2 groups of techniques, and then you can compare. And you can focus on the technical issues in general, like, for example, how accessibility is measured. And you can classify the different techniques by, say, there are some equation-based methods for analyzing accessibility, and there are some network-based models to analyze accessibility. So I think it would, like the way you're classifying articles would depend on what are available, and also, of course, your question. So yeah, that's a requirement. I hope that makes sense. But also, I think if you're still deciding on a topic, so you may want to spend some time to really have a narrow down your ideas, so that like when you search for articles, you can have some more specific keywords in mind. And this assignment, you will have 2 weeks. So 2 weeks from today, so we'll have some time to meet and talk if necessary. But I hope, by the end of this assignment, because all the smaller project assignments are for you to make progress towards figuring out a topic, deciding on like what to do. So I know it's just like one of the assignments you have to turn in, there's a deadline, but I hope you can take the opportunity to try to really make some progress so that like whatever you do, that will, basically count towards your final project. And also, those articles, those 15 articles are, essentially what you would talk about, include in your final paper's literature review section, which is very simple for the class paper. Only, I don't quite remember how many pages I recommended, but I believe it's it's under 2 pages. So simple literature review, but it need to be, relatively complete in terms of the structure. You don't necessarily review all the related articles, but you should have a structure idea on, like why this question is important and why GIS is useful and how GIS is used. Does this make sense?
Yeah, Ting, I might have missed the last part there a little bit. We need to write a summary as well that relates to the 15 articles.
No. So I'm not
Okay.
looking for a summary, but I'm looking for, so the idea I have is by, just grouping the articles,
Right.
you kind of like have the summary in mind.
Okay.
I don't really need you to turn in the summary, but I think, and depending on the style, like your study style or your reading style, you may want to also do some quick summary for yourself.
Okay. Yeah, okay. Thank you.
Ting,
Yes.
in my case, there may not have been, GIS may not have been used for this specific question. So what I've been looking at now is sort of how's GIS been used for traffic analysis, health and sickness in urban areas, crashes, the distribution of crashes, access to park space. So it's sort of things that are related, but not exactly the same thing.
So if you're studying something that, somehow GIS hasn't been used extensively, first of all, I would make sure the data are, or it's possible, basically make sure it's possible because, we're in 2020. So yeah, a lot of things have been done. So it's really making research difficult because you're just trying hard to find a research gap, but somehow everything has been done and it's hard to find a gap. But, it's something we have to deal with, especially with GIS. There are people like publishing 50 papers a year and studying anything they can find. So if that's really the case, I would make sure the data are available, or I would also go with maybe similar research using GIS. I couldn't really name anything specific in your case, Andrew, but maybe like GIS for, like urban land reuse or, things along that line, so that you can borrow their research methods, or, or maybe things on how to measure road width or like length, like more like you can separate them into smaller components, but still use GIS.
Yeah, the second thing is what I was thinking about.
Remote sensing, maybe.
What about like shifted traffic patterns? Like, looking at like, so one when a roadway is closed for construction, like what happens to those traffic patterns? Like, does that make sense? Am I making sense?
Yes.
Yeah, yeah. Any other questions or concerns that regarding the requirements? And well, we basically have 2 weeks to talk about, and I reviewed your, what was the assignment? Yeah, that was the first assignment, your example article. So, I made some comments. Sometimes I think it was just me not really understanding what's going on. So, if you have any questions or concerns, let's make sure to talk, and so that, before you find your articles, let's make sure you have the general idea figured out. Okay, if the requirements are okay, let's take a look at Zotero. I mean, it's not required that you have to use Zotero, but like if you have license for EndNotes, you can use EndNotes, which is actually more functional. There is a problem with Zotero, which well, I guess I wouldn't complain because it's free either way. So once you installed Zotero and also the Zotero Chrome connector, so basically that would allow you will have an account. So everything you save to Zotero will save in your library. They do have a maximum limit, which I think it should be good enough for your class paper and also for your thesis research. I went over, so now I'm paying $25 a year, which is fine for me. But anyways, so once you have the 2 things installed, and as their help document page suggested, you should have the Zotero tab populated on your, basically, in your Word automatically. However, that didn't happen for me. So I had to do this manual installation. Where is my Zoom? I have to send you folks the links. It's kind of hard. Let me see if you folks can do, or you can basically Google like Zotero Word plugin, or I think now you can also scan the QR code. And today I just found out Chrome has this QR code that you can scan and access. But either way, you can do this. So it's kind of like a help page on how to use Zotero in Word. I had to do the installation manually, which they also have a manual installation instruction. So if this somehow happened to you, let me just show you how I had to install. So the way to install the Word plugin manually is not by running any file. It's actually by moving. I think you have to find your installation folder, which is by default, that should be C and program files, and then Zotero, and then extensions, and then Zotero WinWord integration, and then install. And there's a file called zotero.dotm, and you have to copy this file and save this file to your Word startup folder, which you can get from your file options, general, and actually advanced. And then I think I'm actually lost. And then am I searching? Let me just have, I have to read the, okay. Yeah, so you can find out the, the startup default location by, I think it should be this by default. But you can also find out Yeah, and I'm not really sure if you folks need this. Yeah, but it's actually under general and then file locations, and you can copy and paste, this location, then you'll find out the folder, just move this file to that folder. So after you do this, restart Word, and you should have the Zotero. So let's assume you have Zotero tab, and then, now you're writing some paper, you're making some argument, and then you're trying to do a citation. And I actually have, a whole library of things. But for example, you can, when you're on, like in Chrome, you're searching for different papers, sometimes PDF and sometimes maybe the publisher page. There is a tab, depending on the document you're looking at, the icon will be different. But when you hover on, it should say save to Zotero. And actually in your Zotero, you can create different folders. Somehow I decided to update now. And you can create different, you can right click and do new collection. For example, in my library, I have a GS 417 folder. And when you save, when you save your article or save any page or anything, you can choose which folder to save. I think it would be nice if you can choose a folder to save. So now I'm saving this to my GS 417 folder just to stay organized. And by plugging in the citation in your document, you can go to Zotero and then edit citation and choose APA in our case, 7th edition. And then you will see the search bar, and you can search, for example, I'll just search for, just any article, this one maybe, and you hit enter, and that will plug in. And the nice part of this automatic plugging in is if you do multiple citation for the same argument, place your cursor inside, the same parentheses, and you do add and edit again, and you can add maybe say, you can search by keywords. I'm just searching by author. So I'll do this and see they actually sort, like they do the order for you automatically, which is nice. So, they do this order alphabetically. So you hit enter and it will be done. And then you can do more. You don't have to do the parentheses yourself. And I will be doing, some others not this one. So I'll just do this article and hit enter. So when you're done, you can do edit bibliography. Sorry, not this. And enter the reference portion. So the list will be popped up for you. So one limitation of Zotero, and correct me if I'm wrong, because I know some of you have been using Zotero. So, in EndNote, which is another literature management program, they actually link things dynamically. So which means, in that page program, if I delete this particular citation, the one in the list will be deleted automatically by default. However, if I do this, see, it wouldn't delete. They're still there. So which means they're not linking the files. So you still have to, so they're doing the format for you. So you still have to, after you finalize your literature, you still have to check your reference list and make sure you don't have, additional extra ones, or you don't miss any important citations. So which is actually, for those of you who are in the MA program, that's something we do check. And also you have to make sure your formats are okay before you can graduate. So it's an important step. It's a manual step if you're using Zotero, so you still have to manually delete, this article eventually. And also, the exporting is nice, but it's not always accurate. For example, essentially this is a program for doing data scraping. So there could be errors and, like little mistakes. Sometimes the case of names you have to manually change, and also make sure you delete all this DOI links which are not necessary. So there are some cleanup work eventually, but it wouldn't take you more than half an hour. It's still gonna save a lot of time. Yeah, okay, so that's my short demo on Zotero. And I think Google Doc also, yeah, once you have the Zotero connector installed, you will have Zotero in your Google Doc, which it's actually, it's the same, but I found it's slower than, the desktop version, than Word, and you can see it takes a bit to plug in the citation, but it should work. Okay, yeah.
Ping,
Yeah.
that link that I just put in there from the forums for Zotero, there's a macro somebody wrote for Word, but it was quite a while ago.
Okay.
So it's about
Great. Is
halfway.
that for linking?
Yeah, for doing what you just said, I believe.
Okay, that's great.
So the comment came from this date.
Okay. Yeah, so that's 2010.
Well, there's 2013
Okay.
right there, that date right there. The Anticorpo is the name of the person.
Okay, cool. And I think we can also test and see if this works. Yeah, because I was actually searching on the same forum, and there was a post in 2018, and they were just talking about, it's not really internally part of Zotero, but it's nice that there are some external markup we can use and build. I think I will test and I will let you folks know. But either way, I think this should be good enough for the reading list assignment, because we're not really linking, we're not doing any inline citation. So when you're doing this work, I would probably just do a folder for 17 final projects. Oh, and let me show you. So if you have a folder, for example, this is my 15 articles or how many articles, and you can export the citation directly from Zotero by right-clicking on this collection, and you do create bibliography from collection. It's not export collection, because export collection is exporting the whole Zotero document. You're creating a bibliography from collection, and you can choose APA, 7th edition. You do bibliography and also output method save as RTF, which you can open in Word or a text notepad. So I'm just gonna do it here. Well, actually I did it earlier today. So if I go back to my download and double click on the RTF in Word, it'll be a list. So again, you can see it's not really clean. For example, the Clark article, the Sleuth model article, then the names are all uppercase. So you have to convert the case yourself and clean up and delete all the DOI links. I probably should delete the links in the original library, but there are some cleanup work to do just so that you are really APA format. And sometimes
you can. I'm sorry. You can assign tags to your articles. Is it like when you're talking about the classification? Is it possible to have those the bibliography sorted by tags using Zotero, and like have the tags show up on the bibliography?
I usually because I do have tags, but I think because the goal of this program is for the bibliography management. So
Yeah.
the sorting, is kind of just go by APA format. So I think for the purpose of this assignment, I will be just taking them into different orders. And there are also, the exported documents are all sorted alphabetically. So that's part of the API format. Okay. Yeah, I think that's just a demo I have. I'll start.